The objective of this lesson is to solve two-digit by two-digit multiplication problems using the partial product algorithm. In previous lessons, students learned to multiply single-digit by up to four-digit multiplication problems using the partial product algorithm. They used the area model as a visual aid in solving their problems. But today, we will be working with the numerical representation only. As we solve, we will keep in mind the digits value. For example, 24 is made up of 20 and 4. Let's start with our first problem. Chase is excited for his 10th birthday. He has counted 36 days on the calendar until his party. If one day is 24 hours, how many hours until the day of his party? In order to find the answer, we need to multiply the days, 36, by the hours in each day, 24. This leaves us with a two-digit by two-digit multiplication equation. Thanks to the commutative property of multiplication, it does not matter which order we choose to multiply the digits. We can solve this multiplication problem a few different ways. Let's solve this particular problem first by starting with the ones place value of the multiplier of 24, and then move over to the digit in the tens place value. We will be moving from right to left. Since there are two digits in each factor, we will be solving four multiplication problems. We will begin with 4 times 6 equals 24. We will record this product vertically, as well as writing the multiplication problem out to the side. Next, we will solve 4 times 30. It is not just 4 times 3, because the 3 is in the tens place. The answer will be 120. Again, we will record our product, as well as the multiplication sentence to the side. Next, we will move on to the tens place value digit 2 in our multiplier. However, this is not just a 2, it is 2 tens or 20. We will keep this in mind as we multiply. 20 times 6 equals 120. Now we will multiply 20 times 30, which equals 600. Now that we have all the partial products, we can add to get their sum for our final answer. So 24 plus 120 plus 120 plus 600 equals 864. Chase has 864 hours until his birthday party. As mentioned earlier, the order in which we solve our multiplication problem can be switched and we will still get the same product. This time we will solve starting from the left with the two tens and move to the right with the 4. Start by multiplying 20 times 30 for a partial product of 600. Again, write the product in the correct columns and the multiplication problem to the side. Next, we will multiply 20 times 6 for another partial product of 120. Now multiply 4 times 30 for a product of 120. Multiply 4 times 6 for a partial product of 24. Finally, we will add up all of our partial products for a total sum of 864. Chase has 864 hours until his party. Notice that there are still 4 multiplication sentences for each method. They are the exact same 4 sentences, just with a different order. The 4 multiplication sentences we see are 4 times 6 equals 24, 4 times 30 equals 120, 20 times 6 equals 120, and 20 times 30 equals 600. This gives us the same total of 864 hours. It is most effective to choose one method that works and stick with it for less confusion. Now let's try one more multiplication problem using the partial product algorithm. A local chicken farmer uses 58 bags of chicken feed each year. If each bag is 45 pounds, how many pounds of feed does the farmer use each year? In order to find the answer, we will need to multiply the 45 pounds by the 58 bags. Let's solve this problem starting from the right to left. Our first multiplication problem will be 8 times 5 equals 40. Next, we will do 8 times 40 equals 320. Now we will move over to our 5 in the tens place, so we will be multiplying by 50. 50 times 5 equals 250. Next, 50 times 40 equals 2,000. We will now add all our partial products together for a total of 2,610 pounds. The objective of this lesson was to solve two-digit by two-digit multiplication problems using the partial product algorithm, and we met this objective by solving two-digit by two-digit multiplication problems using a systematic approach with the partial product algorithm.